Kotlin is an excellent choice for penetration testing and red teaming tools due to its JVM interoperability, access to a vast ecosystem of Java libraries, conciseness, null safety, and powerful features like coroutines for concurrent operations. Here are some exciting project ideas using Kotlin, ranging from beginner to advanced, covering various aspects of penetration testing and red teaming. So, why Kotlin for security tools? JVM Powerhouse, access to all Java libraries for networking, cryptography, file manipulation, bytecode manipulation, reflection, etc. This is huge. Conciseness and readability, write more expressive and less verbose code compared to Java, leading to faster development and easier maintenance. Coroutines, superb for asynchronous and concurrent programming, ideal for high-speed network scanning, brute forcing, or managing multiple C2 agents. Type safety and null safety, reduce common bugs and makes your tools more robust. Multi-platform potential, KMM/native. While less common for server-side pen testing, Kotlin Native opens doors for creating agents that compile to native executables for different OSs, potentially avoiding JVM dependency. Scripting capabilities. Kotlin can be used for quick scripts, similar to Python, but with JVM performance. So, project ideas. Reconnaissance and discovery. 1. Fast network scanner. Port, service, vulnerability detection. Description: a custom network scanner that goes beyond Nmap's basic capabilities for specific use cases. It could perform SYN, TCP, UDP scans, banner grabbing, common service fingerprinting, and check for default credentials or known CVEs on identified services. Why Kotlin? Leverage Kotlin coroutines for highly concurrent port scanning. Use JVM's socket and server socket APIs. External libraries for HTTP/HTTPS requests, KTOR client, OKHTTP for web service enumeration. Key features: customizable port ranges, service-specific probes like HTTP GET requests, SSH banner, simple vulnerability lookup like against a local CVE database or NVD API, output to various formats, JSON, CSV. Learning opportunities: networking protocols, concurrency, external API interaction, data parsing. Complexity: intermediate. 2. Web application crawler and asset discoverer. Description: a tool to crawl a target web application, identify all unique URLs, discover hidden directory/files via common word lists, identify subdomains, and extract email addresses or other sensitive information. Why Kotlin? KTOR client or OKHTTP for robust HTTP requests, coroutines for parallel crawling, excellent string and regex capabilities for parsing HTML/JavaScript. Key features: scope management, request throttling, proxy support, custom headers, JavaScript execution, potentially via Nashorn or Graal VM if needed for modern SPAs, and sitemap generation. Learning opportunities: HTTP protocol, web scraping, regular expressions, front-end technologies. Complexity: intermediate. 3. OSN data aggregator and analyzer. Description: a tool that automates the collection of OSN data from various public sources like Showdown API, Census API, public DNS records, social media, Pastebins, and GitHub. It would then aggregate and present this data in a meaningful way. Why Kotlin? Robust HTTP clients for API interaction, powerful data structures for aggregation, JSON parsing like Kotlin.serialization, can integrate with graphing libraries for visualization. Key features: modular design for adding new data sources, customizable queries, deduplication, simple reporting, data enrichment like GeoIP lookup. Learning opportunities: API interaction, data modeling, information aggregation, data visualization, optional. Complexity: intermediate to advanced. 2. Exploitation and post-exploitation. 4. Custom C2 command and control framework, server and agent. Description: develop a lightweight cross-platform JVM-based C2 framework. The server handles multiple agents, beacons, issues commands, and collects results. The agent executes commands, performs reconnaissance, and exfiltrates data. Why Kotlin? Server: KTOR framework for the backend, REST API or WebSockets, coroutines for managing multiple agent connections, powerful logging. Agent: KTOR client for communication, JVM process execution, file I/O, reflection for dynamic loading. Can be compiled into a fat jar for easy deployment. Key features: secure communication, TLS, customizable beaconing intervals, tasking system, shell commands, file upload, download, screenshot, keylog, process list, simple persistence mechanisms. Learning opportunities: networking programming, secure communication, concurrency, JVM internals, client-server architecture. Complexity: advanced. 5. Reverse/bind shell generator and handler. Description: a tool that generates various types of reverse and bind shells, TCP, UDP, HTTP, HTTPS, in different formats, Bash, Python, PowerShell, Java, Kotlin, and also includes a robust listener to catch these shells. Why Kotlin? Strong string manipulation, template engines for payload generation, networking APIs for the listener, coroutines for handling multiple incoming shells on the listener. Key features: multiple payload formats, customizable obfuscation options, multi-threaded listener, command history, file transfer capabilities within the shell. Learning opportunities: network sockets, shell scripting, encoding, decoding, cross-language payload generation. Complexity: intermediate. 6. Web API fuzzer/JWT manipulator. Description: a specialized tool for testing RESTful APIs. It can enumerate endpoints, fuzz parameters with various payloads, SQLI, XSS, command injection, and specifically target JWTs for manipulation, like changing algorithms, invalid signatures, brute forcing weak secrets. Why Kotlin? Ktor client for HTTP requests, Kotlin.serialization for JSON handling, libraries for JWT parsing and signing like JWJWT, string manipulation for payload injection. Key features, load word list for fuzzing, define custom ATAC patterns, automatic JWT parsing and modification, proxy support, detailed request response logging, learning opportunities, web API safety, JWT vulnerabilities, structured data parsing, dynamic payload generation, complexity, intermediate. 3. Red teaming and adversary simulation. 7. Phishing campaign manager. Description: a tool that automates the setup, execution, and tracking of simulated phishing campaigns. It would host fake login pages, send spear phishing emails, track clicks and credential submissions, and generate reports. Why Kotlin? Ktor framework for hosting the fake web pages and backend API, Java Mail API for sending emails, database integration like exposed ORM with H2 or PostgreSQL for tracking. Key features: email template management, dynamic content generation, victim tracking, credential logging, reporting dashboards. Learning opportunities: web server development, email protocols, SMTP, database interaction, front-end templating. Complexity, advanced. 8. Internal network reconnaissance tool, post-compromise. An agent run on a compromised host that focuses on internal network reconnaissance. It could enumerate local users, groups, running processes, installed software, network shares, Active Directory information of Windows, and perform local port scanning or service discovery. Why Kotlin? JVM process execution, process builder, file system access, network socket manipulation. Can leverage JNA/JNI for calling native OS APIs if more detailed system information is needed. Key features: modular design for various reconnaissance tasks, data collection and exfiltration mechanisms, minimal footprint. Learning opportunities: OS internals, Windows/Linux, system APIs, inter-process communication, file system navigation. Complexity, intermediate to advanced. 9. Payload obfuscation innovation tool, JVM bytecode manipulation. Description: a tool specifically designed to obfuscate Kotlin/Java payloads, JARs, to evade antivirus or EDR detections. This could involve renaming classes, methods/fields, string encryption, control flow obfuscation, or dynamic class loading. Why Kotlin? Uses libraries like SM, Java Bytecode Manipulation Library, or ByteBuddy to directly modify compiled.cls files. Kotlin's strong typing helps in understanding and manipulating bytecode structures. Key features: various obfuscation techniques, customizable settings, input-output job processing. Learning opportunities: JVM bytecode, reverse engineering concepts, compiler internals, low-level programming. Complexity, advanced. 4. Utilities and miscellaneous. 10. Encryptor/decryptor and hash calculator suite. Description: a comprehensive utility for performing various cryptographic operations, encrypting/decrypting data using common algorithms, AES, RSA, encoding/decoding, base64 URL encoding, and calculating hashes, MD5, SHA1, SHA256. Why Kotlin? JVM's built-in java.security and java.crypto.packages, excellent for building a robust and secure utility. Key features: support for multiple algorithms, key management, file encryption, clipboard integration, command line interface, or simple GUI. TornadoFX Compose Desktop. Learning opportunities: cryptography principles, secure coding practices, key management. Complexity, beginner to intermediate. 11. Log analysis and anomaly detection tool. Description: a tool that can ingest various log formats like access logs, system logs, and apply rules or simple machine learning models to detect suspicious patterns or anomalies. Why Kotlin? Powerful data processing capabilities, Kotlin.serialization for parsing structured logs, potentially integration with data science libraries, though Java-based ones would be used. Key features: customizable log parsers, rule-based detection, time series analysis, alert generation. Learning opportunities: data parsing, pattern matching, basic anomaly detection techniques. Complexity, intermediate to advanced. So, getting started. Choose a project. Pick one that excites you and aligns with your current skill level. Don't be afraid to start simple and add features later. Set up your environment. Install IntelliJ IDEA. Community Edition is free and excellent for Kotlin. JDK. Learn Kotlin basics. If new to Kotlin, go through a tutorial or two. Leverage libraries. Don't reinvent the wheel. Networking. Ktor client, OKHTTP, Ktor framework. Serialization, Kotlin.serialization, JSON, XML, protobuf. Concurrency, Kotlin co-return. Databases, exposed. UI, optional, TornadoFX, JVM, or Compose Desktop. Bytecode, SM, ByteBuddy. Start small. Implement the core functionality first, then iterate and add features. Ethical hacking. Always ensure you have explicit permission to perform penetration testing activities on any target system. These tools are for legitimate security testing only. Good luck and happy hacking with Kotlin.